All right, so let's get into a word problem. So Kristen spent $131 on shirts, which is far too much money to be spending on shirts, if you ask me. Oh, she bought fancy shirts, so I guess that explains it. So fancy shirts cost $28 and plain t-shirts cost $15. If she bought a total of 7, then how many of each kind did she buy? Okay, so just like any word problem, we are going to have to figure out all the information it gives us, whether or not there's extraneous information, which remember is just extra information that it gives you that you don't actually need to solve the problem, which happens a lot more often than you think. We're going to need to list out what our variables are and what they represent. Okay, so let's go back and let's look at the actual question of the word problem, which is right here. So how many of each kind did she buy? So each kind of shirt. So we are looking for, let's see, the number of fancy shirts and the number of plain shirts. Okay. So let's just go ahead and call those our variables. Didn't particularly matter which one I labeled X or Y. Just went alphabetically. First one's got X, the next one's got Y. So we said we are going to let X be the number of fancy shirts and Y is going to be the number of plain shirts. So this word problem has to do with systems of equations. Okay, so we are looking for two different equations. Okay, so let's go back to our word problem and let's see if we can. I'm going to go ahead and erase this because we don't need it anymore. We already have it on the other page. Let's see if we can use the information to come up with a couple different equations. So Kristen spent $131 on shirts. Okay, so we know that she spent a total of, total spent was $131. Fancy shirts cost $28. $28 and plain costs $15. Okay. Okay, so I think that gives us enough to go ahead and give us one equation. So we know that however many fancy shirts she bought, she paid $28 for each of those shirts. Okay, and same thing with the plain shirts. For each plain shirt that she buys, she spends $15. So if we add up the number of fancy shirts times the price of each fancy shirt, and we add that to the number of plain t-shirts times how much it costs, we should get the total amount of money she spent. 28 times, well, however many fancy shirts she bought. But if you remember, we said that however many fancy shirts she bought, well, we were going to call that X. Okay, so we can just multiply this 28 by our variable X. Okay, And then we need to do the same thing with the plain shirts, but we need to add it to how much we already spent on fancy shirts. So the cost of each plain shirt times how many plain shirts she bought. Okay? And this is going to total $131. Okay, cool. So we have our first equation. Let's go back over here. Equation 1. 28x plus 15y equals 131. All right. Now let's see if we can get a second equation. Well, the only really other thing is it tells us that she bought a total of 7 shirts. All right. Okay, well, so if we just take however many fancy shirts and add that to however many plain shirts, well, we should get 7 total shirts. Okay. So again, our number of fancy shirts was just X, and our number of plain shirts was just Y, and that is supposed to equal 7. Perfect. Okay, so equation 2 was X plus Y equals 7. All right. Perfect. Okay. So now we have our system of equations, and I'm just going to I'm going to circle it. We're not done, but now we are at the point where we can actually start doing some algebra and solve for x and y here. So like we did in the last problem, we had 2 equations, we graphed them, and we looked for their intersection point. Well, that's just one of the ways that you can solve a system of equations. And we touched very briefly on this while we were still in school. But the way that I'm going to show you how to do to solve this system of equations is using the method of substitution. So we're going to solve with substitution. Okay. And basically, just like a kind of the view from 10,000 feet, is where you're going to essentially solve for one of the variables and then in one of the equations, and then plug that in for that variable in the other equation. Okay. So let's just see how this works in action. So we've got our 2 equations, 28x plus 15y equals 131, and x plus y equals 7. Right. So it looks like if I take equation 2, it looks like it's going to be easiest to solve for one of the variables in equation 2. Okay. And it doesn't really matter, you could pick x or y. I'm just going to choose to solve for y. And so, let's see, so step 1, I'm going to solve equation 2 for y. All right. So we have x plus y equals 7. Well, to solve for y, I just need to subtract x from both sides, and I get y equals 7 minus x. All right. Now, step 2 is I'm going to plug that in equation 1. Alright, so I'm going to take equation 1, which was 28x plus 15y equals 131. And for y, I'm going to plug in what we got over here. So we said that y was equal to or the same thing as this expression 7 minus x. Okay, so I'm going to replace y with 7 minus x. So we have 28x plus 15 times 7 minus x, which is the same thing as y. All right. So now we just need to use the distributive property here. So we have 28x plus 15 times 7 is going to give us 105. And then 15 times negative x is negative 15x. It still equals 131. Let's combine our like terms. Boom and boom. 28 minus 15 is going to give us 13. So we have 13x plus 105 equals 131. Now I just need to solve for x here. So we have 13 times x. We can't deal with that yet because we have this plus 105. So we need to do the opposite. So we need to subtract 105 from both sides. We get 13x is equal to 26. 131 minus 105 is 26. Perfect. All right. And now we can deal with the 13. So 13 times x, so we need to divide on both sides. And we get x equals 2. Okay, still not there yet, but getting close. So now we just need to take this value and plug it. Now it doesn't matter. We can plug it into either one of the equations and solve for y. As you guys can probably see, it's going to be easiest if we take from this one. So let's just go ahead and plug in x in for 2. So I'm just going to come up here and say step 3, plug in solved variable to solve for remaining variable. Okay, and so we're going to take x plus y equals 7, plug in 2 for x, subtract 2 from both sides. We get y is equal to 5. Okay. Great, so we have an x and a y. We are just about done. So we could just say step 4, write the solution. And remember, solutions to systems of equations are ordered pairs. So our solution is the point 2, 5. All right, and remember this one was a word problem, so we need to answer in a complete sentence. So let's quick look back just to remember what was going on. So Kristen was spending way too much money on shirts, and she was buying fancy shirts and plain shirts. So we say Kristen bought 2 fancy shirts and 5 plain shirts.